In this video, we're going to look at factoring polynomials. One way to find the roots is if we can put so we can factor out a common 2. We're left with 2x squared minus 5x plus 9. We'll look at other ways to deal with the rest of that in a little bit. If we can, who knows? Last one, it's not only numbers that we can look for. On this last one, all three of these have a common factor of x. So we take out the x, and we got x squared plus 11x plus 9. That's especially nice because we took it from a trinomial down to a binomial. It's always easier if we can reduce the degree. But what do we do with these trinomials once we get to those? Factoring trinomials, I'm going to break into a couple steps. First step, or it's the easiest ones, I should say, are when the leading coefficient is 1. We just have an x squared. We're going to take advantage of our Punnett square when we look at these. If you remember back when we were multiplying these out, when we plugged in our binomials into the square, the x squared term always is in this top box, and the constant was always in this bottom box. So we'll fill that out. The last two boxes, they have to add up to be that middle term. So that's a little harder to figure out, so we got to work to that. But x squared is pretty easy, that's x and x. But when we look at 12, what multiplies to be 12? I could be 1 and 12, 2 and 6, or 3 and 4. So those are all options that I could put for these two spots. This is where I got to look at that middle term. Because I'm to have x here and here, whatever number I put there is times x. I'll get those two numbers in these boxes. They have to add up to be 7. So I look at my options. 3 and 4 add to be 7. So I put a 3 here, 4 here, 4x, 3x gives me 7x. That's good. So I can write down my answer, which is x plus 4 times x plus 3. This process of factoring is basically guessing and checking. We look and see what numbers multiply together to be this last number, and then see which ones will add up to give me my middle number. Let's go ahead and look at this other example. We'll start with our box. It's just a nice little tool that helps organize my thinking, so I kind of like it. I'll put the x squared here, so that has to be x and x. Now in this case, I have the negative 24, so since that's negative, I know one of my factors is negative and one is positive. So again, I'm going to go 1 and 24, 2 and 12, 3 and 8, 4 and 6. But I'm going to have it either these are negative and those are positive, or I have 1 and negative 24, 2 and negative 12, 3 and negative 8, 4 and negative 6. So I got to consider both ways. I'm trying to get to my 5, so I'm going to get 5 by taking a negative 3 and 8. So we get negative 3x, 8x. That'll add up to be 5x. Looks good. X minus 3, x plus 8. You can see you can do this idea without making your box. But making the box, again, helps you organize and kind of can help you think through these ideas and work them through here. Now, it gets a little bit more difficult when we put leading coefficient. We put a number in front of that x squared that's not 1. Now for this first example, isn't quite as bad because I can look and see, yeah, I got a 3 there, but 3 is a factor of 15 and 3 is a factor of 18. So if I factor out my 3 first, I got x squared plus 5x plus 6. Anytime you can factor out a common factor, it's going to make the number smaller, and it's going to make it easier to figure this out. So now I can put my x squared here. I put my 6 here. 6 is either going to be 1 and 6 or 2 and 3. These are the ones that will add to 5, so I'll go 2 and 3. Because 3x plus 2x equals 5x. So this is going to be 3, because I can't forget that 3. X plus 2, x plus 3. When I look at this next one, though, 5 is not a factor of either one of these, so I can't factor that out. So I have to put 5x squared in the box. So this is now going to be an x and a 5x, because these have to multiply to be 5x squared. When I look at 8, I can do 1 and 8 or 2 and 4, but it's negative. So I can have a negative 1 and 8, a negative 2 and 4, or a 1 and negative 8, and a 2 and a negative 4. So I only have 4 options. That helps me out a little bit. But the other thing I got to worry about is I can't just say these add up to 18. Well, none of them add up to 18. But here's the problem. I got this 5x over here, which means whatever I put over here in this box is going to be 5x times that number, not just x times the number. So if I just go and try something and say, let's put a negative 1 and 8. 8 times x is 8x. 5x times 1 is a negative 5x. That's going to add up to 3x, and that's not going to work. But now, does that throw out 8 and 1? Well, I could have a negative 8, but I could also, 5x squared negative 8, I could also put the 8 here and the negative 1 here. Now we have 5x times 8 is 40x, and x times negative 1 is a negative x. And that's 39x. Again, that's wrong, but you notice I get different answers if I switch the position of the 8 and the 1. So now, not only do I have 4 choices here to try, but each one has, I could switch them around, so I really have 8 things that I need to try to figure this one out. This takes a little bit more time. It just takes patience, because it's pretty much this idea of guess and check. But if we go 5x squared, 5x and x, this is a negative 8. So I'm going to put 4 here and a negative 2 there. That's going to give me 20x, and negative 2x will add up to 18x. That's the one that works. So I'm going to get 5x minus 2 and an x plus 4. These are the ones that take you the most time. Just have to work carefully. I would not keep erasing things. I'd leave all my work on my paper as I work through this, because one of the things you start doing is forgetting which ones you've tried, and then you keep going round in circles. So work carefully, show all of your work on this. We have some special patterns that help us out when you do these. These are ones that show up a lot, so if you have these memorized, it can speed up time on factoring sometimes. If you don't, you can just keep plugging away with guess and check if you need to. The first one is we looked at when we were completing the square. Is this one, a squared plus 2ax plus b squared equals a plus b squared. So if we look at this example, I got x squared plus 12x plus 36. Well, if this fits this pattern, x squared has to equal a squared. So I'm going to have a equals x. B squared has to be 36. So b has to equal 6. So is 12 going to be 2 times x times 6? And yes, that indeed is 12x. So it fits the pattern. So this is just going to be x plus 6 quantity squared. That's kind of the thought that goes through when we're using one of these patterns. This is one, if you see it, it works quickly. This one I use more often going the other way around. If I have a quantity squared here, a plus b squared, or I have x plus 6 squared, then I can multiply it out really quickly by going x squared plus 2 times x times 6 is 12x plus 6 squared. This next one is one of the nicest ones, an easy one to recognize and pretty quick to work with. We call this the difference of two squares because we're subtracting two perfect squares. And that will factor out to be x squared, or a squared minus b squared, a plus b, a minus b. That's a conjugate pair, if you remember, from our complex numbers. So we look at this example, 4x squared, that's a 2x to the second power. 25 is 5x squared. So this is going to be 2x plus 5, 2x minus 5. Now what happens if it's a plus? If this is plus, we're going to get complex conjugates. So in this case, 9 is a perfect square, x is a perfect square, so that's a 3x, 3x. 49 is a perfect square, so it would be plus 7i minus 7i. So if you're factoring and you can include complex numbers, this pattern is really nice to get you your complex conjugates. If you are factoring and you only need real number factors, then we would say this one does not factor with real numbers. So it's worth noticing then anyway, because you say, hey, I got a squared plus b squared. It doesn't factor with real numbers. I'm done. Last one, this is one that will pop up just when you least expect it. It's the one that we don't memorize quite as well, and we always have to look it up or have problems with it. And most math books, you will have this generally in one of the inside covers, so you can always look it up. But this is if you do the same sum or difference of cubes. A cubed plus b cubed gives us this awful thing. So when we look at this, x cubed plus 8, that would be a is x, b is 2, because 2 to the third power. Whoa! Let's try this so it doesn't happen again. B is 2 to the third power, so this answer is going to be x plus 2, x squared minus 2x plus 4. Now, the thing is, with this one, with this perfect cubes, the sum of cubes, if that's a minus, that one's going to be a minus, and that one's going to be a plus. That still will be a plus. Kind of like up here, with this one, with a plus b squared, if we make this middle term a minus, then that's going to be a minus b squared. But these are special patterns. If you recognize them, it makes factoring a lot easier. I'm going to finish up with just one more example, and this is a trick as these get higher. All of these we've been working with pretty much are quadratics. But what happens if we get to third degree or higher? One thing that can help us sometimes is this idea, this idea of factoring by grouping. When I look at this cubic polynomial here, I'm going to group it into groups. So I'm going to put these first two together, and I'm going to put these second two together. And then once they're together, I'm going to look for a common factor. 3x to the third minus 12x squared has a common factor of 3x squared. And that leaves me with x minus 4. I look at these two, 5x minus 20 has a common factor of 5, and that gives me x minus 4. Now this one works nice here because now both of these groups have a common factor of x minus 4. So I can factor out that common factor from the two groups. And I get x minus 4 times 3x squared plus 5. Then I look and see, can I do anything with that? Well, this is a plus, so if it would factor, I'm going to get imaginary numbers. I'm not going to mess with that, so I leave it be at that. This is one technique that we can use to try to factor higher degree polynomials than quadratics. That wouldn't fit in too well in a Punnett square. The other method we generally use with this is polynomial division, which is what we're going to go into in another video.